Welcome to Algebra 2, Unit 3, Lesson 4. This lesson will consist of recursive functions. Now, before we get into the actual notes of this, I suggest you stop the video and read everything that I'm about to talk to you about. Okay? So read all of page 1. Page 2 here. And then we'll get into this. So at this point, I'm assuming you have read first those 2 pages, because getting into this really does depend on your preparedness and reading the material beforehand. So recursive function, as our notes have told us, is basically a repeating function. You get the answer from the first thing and put it right back into the function to get the next answer. Now, over here, in a repeating function, these are not f of 0. That doesn't mean you put in the number 0 into the f function. This is the order in which these things happened. Okay? What it tells us is that for the 0 function, that means the starting one, the answer for that one was 2. Well, if we want to get the second function, which is the number 1 function, we take the answer from 0, plug it in for x. 2 times negative 2 plus 3 gives us the negative 1. Negative 1 is the answer for f of 1. So we take negative 1, plug it into the f of 2 function, which is the exact same function, except we replace the variable x with the answer from f of 1. And again, you keep going down the line until you get to whichever answer or whichever solution we're looking for. All right? So it says f of 0 is 2. Take the 2, put it into the f of 1 function, get the answer of negative 1 right there, and you keep going down the chain. So these are called chain or repeating functions. Right? The easiest way to do this is start this. Now this says f of x plus 1. This is just talking about the previous function. Okay? So we're saying that f of negative 1 or negative 2 is equal to 0. So right away, we just want to go in order straight down. We talk about f of negative 1, f of 0, f of 1. So we just go down the line. Right? And now we don't focus on this side, just simply focus on here. This f of x stands for, we just change the entire thing into a parenthesis. So I rewrote everything. If you just look at this, 3 times parentheses minus 4, 3 times parentheses minus 4, 3 times parentheses minus 4. So start with the negative 2. Negative 2, f of negative 2 is 0, so I take the answer of 0, plug it into the negative 1, f of negative 1. Okay? 0 times 3 is 3, minus 4 is negative 4. Take that, so f of negative 1 is negative 4. I stick the negative 4 into here and go down the line until I finally get to the f of 1, which is negative 52. Put the answer there. Okay, so again, you just start with one thing and you continue to put it in and in again and again. Okay, so this is the example. I know this is very remedial. Copy this one down, try it out, and see what happens. Okay, in example number 4, okay, we start with f of 2 times, and this is where we replace the f of x, we just change that to a parentheses, plus 1. Okay, now this working backward stuff, we are not going to do. Okay, so don't worry about this particular page. And on the homework, whenever it says working backwards, we're also not going to worry about this. But in class, we'll go over this just to give you guys an idea. The next part, which is function applications. Now, this is how recursive functions work in real life. Okay, it says in our town, NC drivers caught speeding are fined according to the following table. If you're driving 35 miles per hour or lower, you get no fine. At 40 miles per hour, you get charged $40. At 45 miles per hour, you get charged the fine for $40 plus 10% of that fine. So here it is. Okay, we always round up. So at 40 miles per hour, you get charged $40. Let's move this thing up. At 45 miles per hour, you get charged the $40 fee plus 10% of that. So 10% of 40 is 4. 40 plus 4 is 44. At the 50 mile per hour, you get charged the 45 mile per hour fee, which is $44, plus 10% of that, which gives you 48, 40. At 55, you get charged the 50 mile per hour fee, which was this, plus 10% of that, which makes it 53. Okay? And at 60 miles per hour, you get charged the 55 mile per hour fee, which is there, plus 10% of that, which gets you here. So again, at the 60 mile per hour, we get charged 58.56. Well, why is 57 58.56? Because we round that up to 60. That's what it gets us there. Right? And number 2 says customers making collect calls using Rhapsody Phone Company will cost $2.15. Any call lasting over 3 minutes will cost an additional 50 cents. Well, the equation that we write for that, this is very similar to a person that's working and gets a bonus for selling X number of shoes or X number of computers over a certain amount. Same thing. The cost of a phone call is going to be $2.15, but it's going to be 50 cents for any minute after 3. So we write it f of x is equal to 50 cents, parentheses x minus 3, and if x is greater than 3, and we get this, if x is less than 3, it's still 2.15. So we're going to have to basically write 2 equations, one for x greater than 3, one for x less than 3. So if we plug in 5, we get this. If we plug in 7.5 minutes, we get that. Sorry, I didn't see that. So here is the notes for that particular piece right there. Let me go ahead and copy that down quickly. All right, if you guys need to pause it, go ahead and pause it at this moment. I am switching the page. All right, a stockbroker charges $125 to handle any transaction. In addition, he charges 50 cents per share traded. Write a linear expression. Well, we're talking about the number of shares being traded, so that is going to be the variable that we don't know. So it's 50 cents per share plus a standard charge of $125. Personally, I would never go to a person that charges this much, but let's go ahead and follow this example and move on. State a reasonable domain. Well, a reasonable domain, it has to include all natural numbers, first of all. You're not going to make a negative number of shares. That's excellent. You're not going to buy 0 shares, because if you tell the guy, I'm going to buy 0 shares, he's going to charge you $125 just for talking to him, and that's not going to make sense. So whole numbers are out. So natural numbers, the counting numbers, are the ones that we want. Now, if we set y equal to 0, we can find that 250 is a number that comes out, which would break even for the cost and everything. So you need to buy at least 250 shares to make a reasonable estimate. Now, for this one, we stick in 1,300 into here, and we get the cost for the transaction itself. Now, in addition, you're going to have to charge, add on the number of, what the price of the $1,300 shares itself were. So, in addition to your cost of the stock itself, you're going to get charged another $775, which is extremely, extremely excessive. And finally, okay, Diana has opened a new savings account with $250. She has decided to have $225 directly deposited into her account each month. So your starting point is $250, and every month you're adding an additional $225. So your equation is 225x, because then you don't know how many months you're going to put in. So that's your variable, and this is your starting point. So you can change the letter variable x to that letter m to stand for months, to be a little bit more descriptive, right? And it says how much will be in the account after a year and a half. Well, don't put 1.5 in here for x. Year and a half, remember, our equation is written in months, so we have to put year and a half as 18 months. So we stick the number 18 in here and get 4,300. Right? I hope you guys had understood, but please, we will be going over recursive functions, so come up with questions so we can answer them in class.